Hi everyone, welcome to Foresight Biotech and Health Extension Seminar Group, sponsored by 100 Plus Capital. Really excited to have Sofya Lebedeva here with us today. She started a really fun new molecular meditation group at our Vision Weekend as one of our fellows this year. And I think you just have such a vast array of interest areas and I think really focus areas in which you engage with the world that it's really exciting to have you on here in our biotech group. And today you'll be discussing beyond microbial resistance, but you also have lots of other interests, including effective altruism and so forth. So I'm really excited to maybe dig into a few of those as well during the Q&A. But for now, I really couldn't be happier to have you here, finally. I'm going to share much more info about you in the chat for people that are here with us, and it will also be on our YouTube description if people want to read up on it. But for now, the stage is yours. Please take it away. Thanks a lot.
Yeah, thank you so much. Thank you everyone so much for being here. I'm Sofya, and so a little bit about me, I think before I get started is, so I'm currently doing my PhD at Oxford. My background's in molecular biology, and then I'm also, Alison has briefly introduced some of my interests already, but I am interested in effective altruism, antimicrobial resistance, biosecurity, and then some of my other research focuses on immunology. And lightly, molecular meditations was also mentioned. So if we have time in the Q&A, happy to speak more about that. Just to get started, I want you to think about a technology that could extend your life by 20 plus years. So please put a few examples in the chat, or feel free to unmute yourself and say one out loud. And I will painfully sit here until somebody says something. There we go. Beautiful. Partial reprogramming. Interesting. Super cool. Anyone else? Body replacement, nanorobots. Also really cool. Super antibiotics, interesting. Hey, telomere length extension, and then biopreservation. Yeah, really exciting. So a ton of different things that we can see going on already. And I think you already knew what I was going with this, but we actually already have one, and that's antimicrobials or antibiotics. So because of antimicrobials, many of us no longer have to fear things that are quite dangerous to us. So essentially, when you are a child and you get a cut in the garden or something like that, you don't have to worry about no longer continuing to live, because we have this safety net that allows us to pretty much go on about with our daily lives. Antimicrobials enable surgery, cancer therapy, and other critical care. And I think it's one of those things that people just don't think about, and I certainly have taken for granted as well. But the WHO estimates that returning to a world without antimicrobials would result in a decrease of human life expectancy by 20 years, which I think is quite relevant for some of the kind of health extension topics as well. So I have a few discussion questions about that coming up in the future. So my goals for the talk are to present the problem posed by antimicrobial resistance, and then to also provide an overview of the possible solutions to it, as well as introduce AMR, so the nonprofit that I've co-founded, and our work, and to provide an overview of our current projects, how you can get involved, get feedback on them, get critiqued. I would love to hear critiques on any of our work. That would be very helpful. And then also to generate interesting discussion on AMR health extension, as well as just the interplay of antimicrobial resistance with all the other issues that I think about, and hopefully other people here think about, because I think the intersections of those are really interesting. And I will also periodically monitor the chat, but just if I do miss something, feel free to unmute. Yeah. And now a little bit about audience participation and accessibility. You guys already saw that if we see like this sort of icon, I'm going to be expecting people to participate. So that would be great. And then a note on accessibility is if there's any figures or anything that is not accessible in terms of colors or wording or anything like that, feel free to contact me privately. I can update them and send you the slides again, or we can take a pause and I can explain anything verbally. Or any other accessibility issues, please don't hesitate to unmute. So what is antimicrobial resistance? Antimicrobial resistance is when bacteria evolve to become resistant to current antibiotics, so things that we use. And so the current medicines that we have no longer work. So for example, you would get prescribed something, you would get an infection, you would get prescribed something, and that thing would no longer work. And there's a number of ways in which that happens. So first, that would be the antimicrobial, or like the antibiotics itself, doesn't reach the target. So what that would mean is the pump of the antibiotic so the antibiotic is pumped out of the cell, or it decreases the permeability of the membrane, or it destroys the antibiotic itself. So there's a lot of different ways in which bacteria can evolve to do this. Another option, or another way in which they grow resistance, is they modify or bypass the target of the antibiotic. So they can camouflage, they can express alternative proteins, they can reprogram the target. They're really clever, and there's a lot of ways in which, and this is a constant battle that whole research institutes are working on. So just having given you a bit of a flavor of how complex it is, it also affects pretty much the three key areas. I don't really like the term One Health. I find it quite frustrating, but I do think that it is appropriate to use that here because we do overuse antibiotics in livestock. We also do use a lot of antibiotics in humans. And then there's also a lot of environmental effects with environmental runoff that occur. So for example, like there's like a lot of wastage gets put into the water supply and then that drives resistance further. So here I am going to outline some of the key drivers of AMR, and I would love some, again, audience participation or kind of your opinions of maybe having heard of what I just described. Maybe you have a natural intuition against something else. So we outlined the use of antimicrobials in agriculture as one of the main drivers. Overuse and misuse in humans is another crucial driver. And then a lack of access to appropriate antimicrobials as another driver. So for example, for that is people in the global south don't always have antimicrobials, the right kind, or they're not able to get them in an easy way. So when somebody needs one, they don't have it in stock. Or for example, they get prescribed a much more harsh antimicrobial. And then another is manufacturing runoff. Yeah. Does anyone have any thoughts as to maybe there's any other factors that I'm missing, or maybe there's one that's most important of the ones that I've seen or of the ones that I've highlighted as a driver? I want to actually see the chat. So maybe, okay. No worries if not. Okay, I see someone. Yeah. Okay, Alison, you think that the agriculture one is important. Yeah, if anyone else has any thoughts as to which one is more important, maybe manufacturing or agriculture or animals or humans, let me know. I think it's just interesting to see what people's natural inclinations are. And I don't think we have particularly good answers about this. So it's just interesting to see. So we have the kind of these factors in particular lead to the collapse of the antimicrobial pipeline. And then also the increase of international travel also worsens this as well, because naturally, because of an increased mixing, it continues to drive it further. And we have antimicrobial resistance. So AMR is also a global threat. So 1.27 million deaths per year are attributable to AMR. That's actually higher than malaria and HIV, according to at least the statistics that I found. I want to note that it's difficult to attribute every death to antimicrobial resistance, because sometimes when someone dies because an antibiotic stopped working, but they came in with a particular underlying cause, the death rate or their death gets attributed to the underlying cause, not the antibiotic, even though what they had was treatable. It's just that the treatment didn't work. So I think that's also an important thing to note. And then it's estimated that by 2050, we're going to have 10 plus million deaths per year, which is going to overtake a lot of the other kind of large diseases. And it will have a 55 billion in economic losses in the US per year by 2050 as well, which is huge. And then despite the huge economic losses in the US, actually 90% of this burden will be in the global south. So a lot of the solutions and the kind of factors I'm going to be talking about in the future of this presentation relate to that as well. So the rate of resistance to all antimicrobials is increasing globally. I think that you guys can see a trend that I'm highlighting here. Nothing much else to say here aside from the fact that it's increased from 15% roughly to about 40 in the last 20 years. So it's definitely steeply increasing, and it's difficult to say whether this particular trend will continue, but it's definitely a concerning trend. And then there's a three-pronged solution to antimicrobial resistance. So we have, it's called a tripod. So we can think about access to antimicrobials, we can think about stewardship, and we can think about innovation. If we have access, so without stewardship, essentially access helps ensure that people who need antimicrobials, whether that's in the global north and the global south, everyone that needs to have access to them is able to have access to them, instead of needing to rely on black market sales or stockpiling, or needing to think stockpiling of antimicrobials. There's also stewardship. So that is ensuring that the current antibiotics that we have on the market are used correctly. So for example, if a doctor prescribes one course or two courses, they shouldn't prescribe 3 or 4, or they shouldn't give too many packets, and making sure that we're using them, the current ones that we have, as limited as possible. So in cases where it's uncertain whether to prescribe an antibiotic or not, edging towards not prescribing, and there's specific structured access models to that as well. That's a really complex issue, but there's a lot of great work happening in that case as well. And then innovation is how do we actually make sure that we are generating enough antimicrobials? Yeah, sorry, I have a question about what does the 40% AMR figure actually mean? Let me just go back to that. Sorry, I think, there we go. Yeah, so I will try my best to explain this, but the rate of resistance means that if you sample a percentage of bacteria to a particular common strain or to a common antibiotic, 40% of them will now be resistant to some of the common. There's like a list of common antibiotics that we need to now replace, or we need to develop new ones for, because now in a common population, naturally, this is biases of the sample that was studied. 40% of that bacteria will be resistant to that particular antibiotic, which means that it's very unlikely to actually work with its intended use. Hopefully that's helpful. Thank you for the question. So just to go back and really summarize, there's a three-pronged solution to the problem of antimicrobial resistance. We need to have better access to antibiotics. We need to have better stewardship of antibiotics, and we need to also continually make new antibiotics themselves. And if each one of the prongs of the stool needs to be functioning, otherwise the whole thing falls down, and you can't just be really good at two of them or one of them. They all need to be present. Otherwise the problem just continues to perpetuate. And yeah, so there's a stagnation in terms of innovation that's currently happening. So in order to combat the current problem, we need to develop 10 to 15 new antibiotics per decade to stay ahead of AMR. And four or more of these need to be novel per decade. And when I say novel, what I mean by that is they need to have a new mechanism of action because of the mechanisms that I outlined in the beginning. So there's either bacteria either able to destroy the antibiotic, or they're able to camouflage, or they're able to express alternative proteins. So the current mechanisms of antibiotics that we have don't currently work. We can't just make a slightly different one with a new mechanism. We can't just make a slightly different one with the same mechanism. We need to develop a new class of antibiotics, or at least a new antibiotic within a subclass. And the current state of this, unfortunately, that only 1.3% of drug candidates from 15 big pharmas are antibiotics. So we're really not hitting those targets, and we're not working on that appropriately. And the antibiotic R&D has also fallen since the 1980s. So we used to have around just under 20 antibiotics being approved from 1980 to 1984. And then that figure has basically continued to fall down quite steadily throughout the years. And unfortunately, we're not developing new antibiotics at the rate that we need to be developing them at the moment. And the reason for that is for a lot of the market failures, which I will go into in a bit. So there are also fewer pharma companies in the game naturally because of this, because when we develop a new antibiotic, we need to use it essentially very little. So once we develop something new, we need to actually use it very little, because the whole point is that we develop something and then we use it very little. So we keep it as a late stage reserve. And naturally, when a pharma company wants to develop a new drug, they want as many people to use it as possible. So this is very counterintuitive and very counterintuitive to the current profit structures or incentive structures that are in place. So because of this, there's a huge decrease or decline in the number of pharmaceuticals that are currently developing antibiotics as well. And so the cost to sales ratio is not currently worth it. So the cost of developing a new antimicrobial is very high, and the limited sale, which I've already explained, make it development very unsustainable. So the current economic structures that are set up don't work. So there are ways to combat this, and this is where the solutions come in. So there's a possible solution is push and pull incentives. So push incentives encourage work to start. So push incentives are things like grants that encourage research into the new class of antibiotics. And pull incentives are paid upon successful approval. So I will go into more of them, each examples of each of these in a bit as well. But visually here, you can see that while the development cost is high and the sale revenue itself is not enough to cover it, if you have sales and push, we're able to push that a little bit further. But if we have sales, push, and pull, then we're able to actually produce a revenue for the pharmaceutical companies to make development of new antibiotics more, incentivize the development of new antibiotics. So a push example, or an example of an org that is working on push. So CarbX funds the development of new antibiotics, vaccines, and rapid diagnostics. And they are targeting the most serious resistant bacteria that are identified by the WHO and the CDC priority list. So these priority lists, exactly as the diagram before mentioned, they look at the percentage of bacteria which have the highest resistance in a given population. And those are the populations, that we need to develop new antibiotics against first, because they're the ones that the highest burden. So CarbX does this kind of work. And then an example of a pull incentive is the UK subscription model. So you can see I've put the Netflix diagram here. It's exactly like that. So regardless if you watch 10 movies in a month or one movie, or you don't even watch any movies at all, you still pay the same price for Netflix. So this is the same type of subscription model that the UK has introduced. So what they've introduced is a financial pool incentive that means that the UK pays the same price a year, so 10 million a year for 10 years. So that's 100 million. And they've also played around with the upper limits as well. But so it's actually 23 million per drug per year. But what the reason for this being is that so the UK has created a subscription model where they pay the same amount for antimicrobials regardless of how much they use them. And that incentivizes the company to develop new antibiotics because they know that they will have a guaranteed revenue coming in regardless if like 5% of the drugs that they produce are used or 100% of the drugs that they produce are used. So yeah, that's an example of a pull incentive. And then another example of a pull incentive is a transferable exclusivity voucher. So that's more of a regulatory pull incentive. So vouchers can be used to extend the market exclusivity of any of the company's products sold to another company, which there's a lot of issues with this particular example. And that's something that the EU Commission has been working on, like a draft bill for these transferable exclusivity vouchers. But personally, like myself and like my team at AMR, we're not very sold on them because the kind of subscription model that the UK uses is better for access and stewardship. It also has a bigger incentive and it's more predictable as opposed to the transferable exclusivity vouchers. And it also doesn't encourage monopolies. The reason why I mentioned that the subscription model is better for access is because pull incentives themselves aren't enough to actually guarantee that they will reduce the burden that's happening in LMICs. So they can be used. So access clauses can be used to reduce the global south burden in AMR through access clauses. And the way that we can do that, or some examples of access clauses that we have is, so pull incentives are awarded on a conditional basis, or they're awarded by a third party, or like the LMICs themselves can participate in pull incentives. So this bit is a little bit wordy, so thank you guys for bearing with me. We're getting to the kind of more exciting or like things you can actually do stuff. But I think that this is really important. So access clauses include, so you can have a conditional access clause. So for example, when you have a subscription model, you can have like you can only approve the pull incentive conditional on innovators supplying new antimicrobials, or you can have a third, or in the same pull incentive that you pass in a policy way, you can have a third party drug licensing agreement that you include in there as well, so that even if the large pharmaceutical companies don't want to market to a particular global south market, then we can still get the drug to where it needs to go to reduce that burden. Or we can also have LMICs themselves participate in pull incentives, but with like GDP matched basis, as opposed to having them front the cost of it upfront, because that would also only just increase the lack of fairness and lack of access that's currently going on in the field. Unfortunately, there's a lack of consensus on which type of access clause would be best. So that's some of the work that we're doing as well on figuring out which type of access clause would be better. Maybe there's one that we haven't mentioned and we haven't come across that actually would be a better idea. So we're in the idea gathering stage for that. And I think naturally at this point comes up the question of, so what does AMR actually do? What does like my nonprofit actually do? So we focus on access and innovation. So we focus on two parts of this tripod. And the way that we do that is we advocate for the EU and the G7, G20 governments to implement pull incentives with LMIC access clauses. What those access clauses look like specifically, we're not quite sure at the moment. But the way that we do this is through a combination of policy design, research, and targeted advocacy and networking. So the current projects that we have is we're working on a pull incentive guidebook. So we're trying to figure out a way to explain what pull incentives are and also to explain how various pull incentives are. I gave you two examples of what a different pull incentive can look like, but there's naturally a lot more like different ways that we can structure pull incentives, and it's really exciting to figure out what they could look like. We're also doing a pull incentive cost benefit analysis. So we're creating a simple key narrative that is understandable to policymakers, because naturally policymakers don't have 30 minutes to listen to a presentation that I give about how pull incentives work. And then we're also conducting a farmer survey to really understand what would make them like find pull incentives enticing, and then also trying to figure out what the key bottlenecks are and like which one of those can be met. And then part two of our current projects is we are thinking quite heavily about LMIC access models. We're in conversation with a number of other groups that are creating So there's a focus group that's happening, and we're trying to like really listen to the people like from this country specifically to figure out what they need and figure out what is the best solution for that. And then so we can include those insights into our policy recommendation at the EU, or I guess more in the Western space. And then we're also naturally gathering support from relevant stakeholders. So if we need any kind of like input from patient groups or academics and things like that, we make sure to strengthen our analyses with, again, like first person perspectives. And we're also doing public communication of our findings just to make sure that anything that we find is quite useful. Yeah. And then in case you're wondering how you can get involved, we're always looking for collaborators. We're always looking for volunteers. We are definitely looking for in-country experts. And then if you know anyone that you think is relevant for us to be connected with, please let me know. And then obviously we're looking for funding for specific projects, but that's if there's anything that was interesting to you from the projects we've outlined above. And now we have the exciting part. So I've written some discussion questions, which I think could be quite cool. And I would love to hear if people are comfortable unmuting. Essentially, is health extension possible? Yeah, without antibiotics or anything else like that. I would love to hear people's opinions. And I have about 2 slides of discussion questions, but we can go back and forth. And this is the end of the presentation. I'm happy to also just take any other questions as well. But yeah.
Love it. Thank you so much. That was really informative. I don't think I had any idea of like how bad the problem was. And also that with different staggering of different solutions, you can actually do much about it. So very cool, very policy entrepreneurial. We have a question. Maybe we can start with just a few possible questions about just understanding, like if in case there's like any bits that didn't get quite caught, and then we move to the discussion questions. And love that you prepared them. And we already have Micah with Micah's hands raised. So if you want to just chime in.
So naively, it seems once some bacteria figures out how to become antibiotic resistant, that strain would rapidly dominate over all the other strains. Yet we don't see that. You showed your chart of 20 years, and it looks like they gained about 20% dominance. Do we know what's currently holding them back from just completely taking over just in the span of a few months or a few years? Like, and if so, could we then strengthen whatever that is that's holding them back?
Yeah, there was a really interesting paper that came out recently about so I guess like another part of the whole like thing that I mentioned is actually modeling how antibiotic resistance works. So there's a paper that came out that describes or that has a visual. Maybe I can pull it up and send it once other people start talking, just so you can have a look at it, because it will explain it a lot better than I can. But my naive understanding of it is that certain strains, just because it's resistant, that doesn't mean that it always becomes dominant, because it might not be the best at gathering food. So it might just not be killed. So if there's like a selective pressure applied by the antibiotic itself and the bacteria is resistant, then that strain becomes dominant. But if a strain develops resistance just randomly, like without the pressure of the antibiotic being like applied on the system in which it's living, it actually doesn't necessarily become the dominant one. So that's why it's a bit more complex, and that's why. And like also, if it's resistant in an animal, doesn't always mean that it's resistant in a human. So there's a lot of those complex interaction about that. But I'm not quite sure. So I'm not sure if there's specific mechanisms that hold them back from becoming resistant. It's more just like it's a complex transfer environment. At least that would be my understanding. Not sure if I answered your question.
Yeah, that did. So the idea being that it is not free for bacteria to be antibiotic resistant. There's some cost that comes with it, and that causes the bacteria to then fail in a kind of more in a non-antibiotic environment. That bacteria then can't dominate. And so I wonder then if the solution here is to just make it so there is lots of space for these bacteria to compete that doesn't have antibiotics. So we just basically, you can imagine just breeding lots of them that force out the antibiotic resistant ones. Then the question is, where do you breed all these? Do you just, is your animal population just constantly bacterially infected and not treated? Like, that's certainly not an easy solution, but I wonder if there's any options there.
So just to make sure that I understood your question, are you saying that maybe we just have a space where we can breed non-resistant bacteria as much as we can? Or basically just to encourage, just to make sure that they're the ones, if they naturally dominate in whatever their environments are, this along the lines of not overusing antibiotics, right? By not overusing antibiotics, we allow the more fit but not antibiotic resistant bacteria to dominate in whatever that space is. I don't know if there's some way we can encourage that somehow. Again, just speculating here. I'm trying to think of how to solve the problem. Yeah, no, I appreciate that. I think that it's interesting because I think that I guess the whole nature of this problem is quite dynamic. So we can't just like, if we could just find like one perfect antibiotic and then you just use that, like the whole point is that doesn't work. Unfortunately, we need to keep, it's all a rates problem. It's like, we just need to keep making new antibiotics to counter the resistance that happens, I think. And then unfortunately, even if we did find the perfect strain of bacteria and spread it, and I guess somehow manage to spread it to everywhere, at least from my understanding, I don't think that would actually work, because then there would still be like, they would still somehow continue to develop their natural process of dividing, and like horizontal gene transfer makes them, there's natural errors in that. So eventually the population would shift in terms of like how, even if we got the perfect thing, it would shift away from something and then it could continue to change. Thanks, Micah.
We have another one from John Ferber, if you want to mute in case you want to provide more color to your question.
Hi. I wonder if you've looked into phage therapy, which is an alternative to antibiotics using viruses that attack bacteria.
Yeah. In terms of like maybe advocating for it on a policy level, is that your question? Or have I looked into phage therapy in general? Sorry, I just want to make sure that I want to clarify that I understand.
I was wondering if you looked into phage therapy in general.
Gotcha. Yeah. So I was at like a BBC, there's a BBC documentary that's coming out on not phage therapy, but like antibiotic resistance in general, but phage therapy was mentioned as part of it. So that's been my exposure to it, as that's the kind of like the extent that it's been there, just because. So I do think it's a viable or like a potential solution. And it does seem like something that is at least like instead, but there's a few startups coming up in the space. So I definitely think that could be possible. I think that unfortunately, just like with like there hasn't been like economic analysis that have been done that would show like how scalable is this. But I think that's a really good question. And I plan to look into it more to like maybe provide like color to the analysis that we're doing, because I do think it's another possible solution. I'm just not sure if it's scalable at the moment, and I don't have the background to say that whether it is or not. But there are definitely
apparently quite a lot of work has been done in Soviet Georgia over the past 40 years or so, and they are still using it, and they have quite a few strains isolated that they grow. So I think it's worth taking a look at what they're doing there.
Yeah, absolutely. I think that my quick kind of like off the cuff take is that from at least like the experience from the documentary that I saw, the phages you had to engineer the phage specifically to each person. So for example, it's like you have, when you're sick and you have the first line of defensive antibiotics, the second line of defensive antibiotics, and they fail. And then by that point you pay like the company, at least like that was in the like film, like a sum, and then they basically engineer the phage to be specific to you. And unfortunately to me, that doesn't seem scalable. But if you can make one that could like just be naturally, like if you can make them cheaper and essentially more accessible, then I think that could be used in the global south. But currently I don't see that being a viable solution outside the kind of like rich Western countries. But maybe I'm wrong.
My understanding is that it doesn't have to be individually engineered for each individual person.
Okay, great. I will look into that. No, that's really great. Thank you so much for bringing that up.
We have another hand raised from Micah. Go for it.
So earlier in one of their slides, you mentioned the billions of dollars in costs in drug development. If you're willing to do lobbying towards politicians and whatnot, it seems like it would be easier to just lobby them to get those costs down. A very significant portion of those costs are regulatory box checking and whatnot, whereas the actual cost of coming up with a drug is nowhere near billions of dollars. You look at all the startups, right? The startups will give you a drug for under 10 million. But then they spend billions of dollars getting that to market. And certainly some portion of that is very valuable. Doing testing and all that is useful. But many people in this room right now will likely tell you that there's a lot of room for cutting those costs down. And so rather than trying to figure out ways to get the benefit to these companies up, maybe we just get their costs down instead. And again, the hard part here is the regulatory lobbying. It sounds like you're willing to do that. And so if you're willing to do that regulatory lobbying, that seems like a great place to devote effort.
Yeah, I appreciate that. I think that that's something that we have looked into, but quite on a surface level. So I have written that down as like an avenue to explore. And I think that's definitely like something that's worth checking out. So I appreciate it.
Okay, any final questions around understanding? Otherwise, maybe we'll dive into one of your top discussion questions. Okay, let's do a discussion question.
Yeah, I think any of these, I would love to hear about it, but I'm curious essentially if, health extension is possible without antibiotics. What proportion of our efforts should be focused on this versus something else? Yeah, anything around this topic is really interesting to me and something I enjoy considering.
Cool. So I would say if people want to submit answers, they can either raise hand, or if you can't speak, you can just drop your answer in the chat and I can read it out and make sure that it's at least considered. And we have my turn again. Go for it.
Feel free for other people to raise your hands. I don't want to dominate here. But regarding your question about these initial questions here, my instinct is that this is one of those problems that as it gets worse, people will start throwing more money at it. And so it's not bad enough yet that it is a top killer, like it doesn't beat atherosclerosis and cancer and whatnot. And humanity as a whole isn't throwing a huge amount of money at it because it's one of those problems that we can solve that later. And I do tend to agree with that point of view in this particular case, because we do know how to make antibiotics. As a society, we know how to develop them. We know how to come up with new ones. We know how to test them, all this stuff. It's just expensive and not worth it at the moment. But even though that chart looks like it's going to go to 100% and we're all going to die, I suspect somewhere before 100%, society will suddenly realize, oh, this is now really important. And maybe that time is now, and that's what you're arguing for. But on the flip side, we still do have atherosclerosis out there, which is killing 50-something thousand people a day, whereas bacteria tend to not be killing 50,000 people a day. And so my gut here to answer the question of should we be focusing all our efforts on this or what proportion is that, yes, this is going to be a problem. It is a problem we know how to solve on a technical level. And once it becomes bigger than the biggest problems we have, I think society will naturally start throwing money at it.
We have Creon with a follow-up question to the current one, unless you want to respond, Sofya.
Yeah, I think I'd love to hear the follow-up as well, and then maybe I can respond to both.
Okay, here's my
Cool,
follow-up.
Creon, go for it.
Okay, can you hear me? All right. While I'm as concerned as the next person about superbugs and antibiotic resistance and general microbial resistance, and recognize the desirability of getting our house in order, both in terms of new products as well as more sensible applications of existing products, like not overdosing livestock with antibiotics and getting them throughout our biosphere when it's just going to just exacerbate the escaped mutants. But okay, however, it was saying that I'm not like antibiotic or something, but in follow-up to what the
probiotic.
Pro-antibiotic. In follow-up directly to the previous questioner, two things. One is the great progress that civilization has made against infectious diseases in recent centuries is arguably often over-attributed to medications, antibiotics, vaccines, these sorts of things. And what's underappreciated is that it was advances in sanitation, sewer systems, better housing codes, this sort of thing, reducing pollution from coal and things like that were just weakening people. Those things arguably were more important, or at least as important, as any drugs or pharmaceuticals. And so I don't want us to lose track of that, because a great portion of the world is still living in slums and favelas and polluted places. And so we can get a lot of these people, and arguably the right way to do it is not to find some drug to sell them or give them, but to raise their standards of living and the quality of the environments that they live within. So that's the first thing. I guess that's enough. I just want to hear your comments on that.
Yeah, no, I really appreciate that. Just to maybe make sure that I've gotten both of the comments that we have. So I guess the first one was that we know how the comment is that we already know how to produce antibiotics, and we know how to get it a problem that we know that we can solve. So even though it's becoming more of a problem, it's fine to throw money at it later, and then it should be solved. Hopefully that's an accurate description of the first point.
That was not what I was saying at all.
But not your point. Sorry, there was a point before you, and I'm trying to address both of them.
From Micah. She's getting to both of them. Yeah.
And then your point, Creon, from my understanding, is that even though we could have antibiotics that we could solve, we could have antibiotics, it's actually possibly better to focus on improving sanitation and other standards and like standards of living in like the global south. And that would actually lead to a higher increase in life expectancy, or that would solve it. That's a more important thing to focus on. Is that?
Well, it's not just that I'm not saying it's more important. I'm saying let's not overlook it. If we're trying to keep people from getting communicable diseases, we would probably like to apply the same techniques that dramatically reduced communicable diseases, bacterial, viral, and all the rest, in the developed countries, which was improvements in sanitation, housing, and pollution regulation. And obviously, it's a good thing on its own to get people more healthy and comfortable, but it would probably really help with the diseases. And then we can apply the antibiotics and the vaccines and everything else to where that simple thing doesn't completely solve the problem. And by the way, it just occurred to me that you can think of like people living in slums and unsanitary conditions without sewers. It's animals living in CAFOs, in those feedlot factory farms. It's the same thing. What's the solution? You cram them together into a literally shitty factory farm and they get sick, so you give them antibiotics. That seems like stupid. It's like, just have them out on the grass where they're healthy, and then they won't need the antibiotics, and then the antibiotics won't go everywhere in our biosphere and make antibiotic-resistant organisms. Anyway, end of rant.
Yeah, no, I appreciate that. And thank you both for sharing your thoughts. I think to address the first point, I think that yes, while it is a problem that we like somewhat know how to solve, I think that we know how to solve it more than, for example, AI safety or like some of the kind of like other biosecurity concerns. I think that it's still a problem that we're not currently solving at a rate that's fast enough. So I think that's an interesting argument of, is it throwing money at this later? Is it like, how bad can this get? And like, how much money would we need to throw at it? And like, how late could we push it? I think that's something that's interesting. That's an interesting kind of idea or a thread for me to look into. And then I think the second point about like access to sanitation and access to like clean water and everything like that, I think that's our biggest uncertainty, is the access part in general of because I agree that we shouldn't, just because like we can make it more profitable for big pharmaceutical companies to make new antibiotics, I'm not sure if that's like really the best thing to do if we can't actually ensure access. And that's why we really need to focus on the access piece in general, because maybe like the whole point is that even if we did give them access, or even if there was access in the global south, that wouldn't make any difference. And that's like the crux of the entire like theory of change, or the theory behind this particular work that we're doing. And if that's like the goal for the beginning of 2024, is to really figure that out as soon as we can, because if that doesn't end up being true, then yeah, naturally all the lobbying and all the energy of lobbying like European governments is like, there's really not much point if the end goal, or like in the end, that access to more antimicrobials isn't actually what needs to happen for like quality of life to improve. So I think that's a really...
I'm super curious if you have any thoughts on, like, any hunches already on which specific governments you are hoping to target first. It'd be like one strategic collaboration that you're doing, and then that may give good results, almost like in this relatively controlled experiment scenario, or like on a smaller scale, and then you can scale it up from there. Do you have a hunch of who would be potentially like pretty receptive to this, and what like a smaller version of this would be that could then escalate?
Yeah, so we have conducted a geographic assessment, and we've also talked to a number of different experts, like in each of the countries that we've considered. And then we've conducted a few like stakeholder maps of the specific country that we're considering as well. So I think that currently we're thinking about the Netherlands, Germany, Italy. So Sweden already has like a pilot that they're doing. There's a number of different countries so Italy has done nothing on this, and that there's like a lot, and it's like finding the balance between, just because they've done nothing on it, is it because they're really not going to do anything about it because their government is completely uninterested in it? Or is it because they haven't thought about it and would actually be willing to do more about it? But I think, again, that's why we have one of the co-founders working on like more of the government or like the EU government stuff. And then we have another, like my other co-founder, working on like access specifically, because I think that, yeah, the whole European piece doesn't necessarily matter if we don't know if it would actually help people and where, like in the places where the burden is greatest. So hopefully that answers your question.
Yeah, Micah has another one here.
Also, John, thank you so much. I will check that out.
As a follow-up to Creon's question, or building on that, the 40% bacterial or antibacterial resistance, is that uniformly distributed across the globe, or do we find that high-density, poor population centers have a higher rate of resistance versus, let's say, wealthy, low-density populations? Do we know details on that?
Yeah, so there's a group that's currently working on creating a better analysis of that, because naturally the like graph that I showed you was just like, this is all we could find, and this is our best average, and this is what we got. And obviously that's a really unhelpful metric. So one of the groups that I'm currently working with, they're trying to build like more granular models of this to see which strain specifically is like higher and more resistant where. And then there's also, is it in like closely, like my hunch would be obviously in like closer and more densely populated areas, that would be the case. But then naturally you run into the classic issue that pretty much most things happen is like the places where you really need to get the data from have some of the like worst quality data. And then there's, again, it's the whole attribution thing, is if a person dies from because an antibiotic didn't work, but they came in with a problem, and their death gets ascribed to the problem that they came in with, but not the fact that the antibiotic failed, we actually then lose whether they actually died from that or didn't. And then there's also a different piece of like, how do you model the resistant strain? Do you get a culture from them when they're in clinic? Do you go out and sample random people in the population? So those are all questions. And I think that, yeah, there's at least like a few teams trying to work on this. I don't specifically work on this, but I think it's really necessary. And if someone for some reason knows people that are working on this, obviously I'd love to chat.
Yeah, it seems like from a capital allocation standpoint, answering that question might be one of the most efficient uses of funds, because if Creon's hypothesis is correct, which doesn't seem very unreasonable at all, then we could verify that. And then instead of spending billions of dollars developing a new drug, you instead spend billions of dollars trying to build a sewer system in a high density area. If that ends up solving the problem better than just making a new drug. But in order to know whether that's a useful use of funds, first step is figuring out, is the problem actually high density, low sanitation, or is the problem the bulk of the problem this bacterial resistance? Especially if we're finding that bacterial or antibiotic resistance shows up faster in those high density, low sanitation environments. Because then, if so, then removing those high density, low sanitation environments from the ecosystem would slow down the rate of growth, or maybe even flip it over and get us back to low antibiotic resistant bacteria overall. And maybe that's a better long-term and more scalable solution than trying to continually fight with antibiotics. But again, we need the data first, like you said.
Yeah,
I
really appreciate that. Sorry.
I'd like to make one follow-up to the previous comment there, which is that I was not claiming that antibiotic resistance is necessarily driven by overcrowding, and poor sanitation and pollution. But I think the transmission and deleterious outcomes from transmissible diseases are exacerbated by these terrible conditions that some people live in. And if what your goal is to get people less dying and more healthy, that's the goal. The goal isn't really primarily about antibiotic resistance one way or the other. We don't want antibiotic resistance. And my other point was that if we don't want it, probably one of the things we could do, whether it's in poor countries or rich countries, is stop blasting it into our food supply, because that's definitely driving resistance. But I'm saying get the sanitation and housing and pollution cleaned up. We already know from earlier decades that when you do that, diseases drop way down. And then resistant diseases will also be less of a problem. It's not like they're going to go away. But anyway, that's it.
Yeah, I think your follow-up makes sense to me. I think you were just clarifying. Is that correct? Was there a question in that? I'm not sure if I heard a question. I think it was more of a clarification.
Yes, correct.
Okay, great. Awesome.
Well, do you want to answer to that clarification before you?
No, all good.
I was just looking at time, and given that we don't have all that much left, I would love to hear a little bit more about. You laid that out already, I think, in your slide before the discussion questions, just like in terms of what your next steps are a bit. And I'm super curious if you could speak to those in a bit more detail. Basically, what would you be up to in the next year or roughly? And especially like any, I guess, either technical challenges that you foresee that you think other people could be helping with, or just general collaborations that you think you're staking out right now where other people can get involved with. That would be really cool.
Yeah, I appreciate that. We are looking to work with Our World in Data potentially. So Our World in Data is like having a focus next year on producing a lot of work on the intersection of like climate change and global poverty, and then like how working on one problem can fix the other. And then one of the meetings that we've had was like, what if we throw antibiotic like resistance into that mix? What does the data look like? So I think that some of the questions raised here, and I've written all of them down, as well as like both the like sanitation stuff and then the kind of like high density proximity stuff, as well as like the relevant like density strains. I guess like the just like resistance of strains as well. I think those are the questions that are really interesting to me, and I think that I will pass that along to them, as well as another group. There's 2 groups that are working on this, and there's another group as well from like the Oxford Biosecurity group. So they will be doing some work on that. And I think that should be really interesting. Other collaborations that we are working with, we're also working with like potentially publishing a few policy briefs. So if people want to help communicating with that. And there's like a number of other organizations in the space that I guess we'll be working on that with. And so obviously we're looking for people to get involved. I think that any sort of fringe ideas, so aside from my work with the nonprofit itself, I also like can help find students or people that there's a number of, because I'm based in Oxford, there's always a number of students or people that are thinking about these issues that are willing to hop on and think about a problem or the intersection of a problem. So if anyone has ideas that come out from this, it's relatively easy for me to find people that could take an idea further. So I think that would be interesting. But yeah, aside from that, I think the projects that we outlined, so like cost benefit analysis of like push pull, and then also the access clauses, and then yeah, I think that some of the modeling stuff, I think that those are some of the key ideas and those are the goals, and hopefully there'll be some positive policy change in 20. Yeah.
Awesome. Thank you so much, Sofya. It was really wonderful to have you on. If you want to drop a link to where people can find out about more about it, feel free to, but it will also be in the show notes whenever the video is published. So you can also just wait until that's done. It should be in a week or so. But yeah, thank you so much for joining. Thanks everyone for the discussion. And we didn't even get to the second page of the discussion questions, but I think that's usually a good sign. Thanks everyone for joining. I hope you all have a wonderful rest of your day, and to see all of you very, very soon. Bye everyone.